Hello, this is Mrs. Ross, and this is 1.5 Operations with Complex Numbers. Let's go ahead and dive into it. I do have this printed out, and it is in the extra copies box in my office, so you're welcome to grab it and follow along and write along if you need to. So, adding and subtracting complex numbers. So here we have 3 plus 2i plus 6 minus 5i. Okay, and we are going to combine, oh no we're not, we're going to combine like terms. So this does not have an I, and this does not have an I. So I have 3 plus 6, which is equal to 9. So I've taken care of those terms. And then, let's use green. And then I'm going to combine this one and this one. So I have 2i minus 5i, which is equal to negative 3i. So my answer is going to be 9 minus 3i. Not bad, huh? Okay, over here it's a little bit different because we have this negative here, which is kind of like multiplying by negative 1. We have this invisible negative 1 here. So the 5 minus 3i is fine. Then I have to distribute this negative 1. So I have minus 5 plus 7i, because a negative times a negative is a positive. Now we can collect like terms. So I have 5 minus 5, so 5 minus 5 is 0. And then I have negative 3i plus 7i, so negative 3i plus 7i, since they're opposite signs, we subtract and take the sign of the larger, so 7 minus 3 is 4, the larger number is positive, so my answer is actually 4i. Okay, down here at the bottom I've got a couple of things from the text. It says complex numbers can be added, subtracted, multiplied, and divided. It says the set of complex numbers is closed for the operations of that. You'll never use what is a closed set other than probably a quiz or a test in this particular class. So a set of numbers is closed under an operation if performing the operation with any element of that set produces an element of the same set. Since the sum of two complex numbers is a complex number, okay, so yeah, if you add two complex numbers and you get a complex number, it's closed. You add two real numbers, you get a real number, it's closed. Oh gosh, that's just a lot of math jargon just to, okay. Multiplying and dividing complex numbers. So what we're going to do here is we're going to multiply the actual numbers. Negative 3 times a positive 4 gives me a negative 12. And then I have I times I, which gives me I squared. Funny thing, I squared is negative 1. So this ends up, the answer ends up being negative 1 times negative 12, or just plain 12. Super exciting. Okay, let's change colors, because why not? Here I'm going to distribute. So I have 5i times 2. I'm going to use this symbol, minus 5i times 7i. Okay, so 5 times 2 is 10. And then I have minus 5 times 7 is 35, I squared. Again, we know I squared is equal to negative 1. So this is 10i minus 35 times negative 1, or 10i plus 35. I think that the common notation is to put the real number first. I wouldn't count either of these wrong. So, okay, let's do this one. This is now you try. So if you want to go ahead and pause the video, try this on your own and see if we get the same answer. That would be super cool. Hint, hint, wink, wink. Okay. Let's distribute this like we just did. 3i times 5 plus 3i times 2i. See, I brought this here, just like I did up here. I brought this here. Okay. 3 times 5 is 15i plus 3 times 2 is 6i squared. Again, I squared is negative 1. So we end up with 15i minus 6, or if we do this in the common notation, I guess is what you would call it. Either one of those is right to me. Okay, did you get it? Did you get it? All right, dividing complex numbers rules. So the conjugate, we talked about this in our first sesh. The conjugate is of a plus b is a minus b. And here is an example of a conjugate. -3 minus 5t, the conjugate is -3 plus 5t. So a fraction that contains a complex number is not considered simplified. A complex number in the denominator. In the denominator. Good enough. Okay. So like for instance, this has one in the bottom and this has one in the bottom. So to simplify this, I'm going to multiply by I over I, because anything over anything is, if it's the same thing, that's just equal to 1. So I end up with 2i over 3i squared. Again, keep in mind, I squared is -1. So this is 2i over 3 times -1, which is equal to -2i over 3. Doobie-doobie-doo-doo-doo. Okay. This is divide, so why it looks all weird, I don't know, but okay. So what I have to do is I have to multiply by the conjugate. So the conjugate of the denominator is that, but I have to do, would I multiply the bottom by, I have to multiply the top by. It's kind of like when you have like 1/2 and you multiply by 2 over 2 and you get 2/4, or you're trying to make fractions, you have to, this has to be the same thing over the top of one another. That makes no sense. Anyway, okay, so now we're going to have to FOIL. So we have 1 plus 4i, 3 minus 2i. So this is the top. So we're going to FOIL first, outside, inside, last. So first is 3, outside is -2i, inside is +12i, last is -8i squared. Okay, then we're going to do the bottom. First is 3 times 3 is 9, outside is -6i, inside is +6i, and last is going to be -2i squared. Okay. Hold on, I'm going to erase this. Okay, let me change colors. So this is going to be 3, and this is going to be -2i plus 12i, which is +10i. And this is -8 times -1, which is +8. So then I can combine those, and I get 11 plus 10i for my numerator. 1 plus 10i. Over. Down here, my -6i plus 6i is going to cancel. So I have 9 minus 2 times -1, which is equal to 9 plus 2, which is equal to 11. So you can leave it like this, or you can do 11 over 11 plus 10i over 11, which would be 1 plus 10 over 11i. You could do that, or you could leave it like this. Okay. I'm hoping, is this the last one? It is not, unfortunate. So this is a you try. So if you want to go ahead and stop the video and try this one on your own, that would be great. Let's see if we get the same thing. I'm going to work through it. So you can pause, see if you get it. Let's see, so FOIL. First is -2, outside -i, inside +6i, 2 times 3i. And then last is plus 3, stop, I squared. 3. Beautiful. And then on the bottom, first is 2 times 2 is 4, plus 2i minus 2i minus I squared. Okay, let me get a different color here. So on the top, we're going to combine this. So we have -2. That's going to be minus 7i. This is negative 1, so this is minus 3 over, these are going to cancel, and I end up with 4 plus, remember this is negative 1, a negative 1. So let's continue. Negative 2 minus 3 gives me negative 5 minus 7i over, this is 4 minus 1, which is 3. So you can leave it like this, or you can do this. That's a 3. My handwriting is atrocious. Either way, this one or this one. Next. Okay, solve the equation. Oh gosh, we're going to get some imaginary numbers here, okay? So let's see. I think we can take 3 out of 75. Let me grab my trusty dusty calculator. Bingo. So if I take 3 out of this, I have x squared plus 25. And that's 3 is equal to x plus 5, x minus 5. And if we FOIL this, we get, no we don't, that's a lie. That is a bald-faced lie. Hold up, let me erase that. All right, let's try this again. I had to check myself before I wrecked myself. This is what we're going to do. So I have 3x squared. I'm going to subtract 75 from both sides. So I get equals negative 75. And then I'm going to divide by 3. So I get x squared is equal to negative 25. And then I'm going to take the square root. So x is equal to the square root of negative 1 times the square root of 25. So x is equal to 5i. It could also, could it be equal to negative 5i? I don't think so. We're going to go with that. Okay, over here this is a now you try, so if you want to pause the video, same thing, we're going to subtract. I think so. That's negative, so then we do the same thing, we square root. I'm going to double check that. Oh, my square did not. Okay, so I just checked, and this is plus or minus. And this is also going to be plus or minus. That's an I. I don't know why it looks like a weird backwards J. Okay, and then simplify these. So here's the deal. I do not think I have enough time in this video to make this, so I think I'm going to make a second video for this. Or I can try. No, I'm not. I'm just going to stop here and then I'll start the next one.